In this lesson, we're looking at ratios and rates and what are the similarities and differences between them. First of all, we'll look at ratios. Ratios compare two quantities that have the same units. So as an example, Billy and Jilly compared how much time they spent on homework last week. Billy spent 18 hours and Jilly spent 15 hours. Express the number of hours that Billy spent compared to the hours Jilly spent as a ratio. There's three ways that we can write a ratio. We can say it's a ratio of 18 to 5, so that basically is using mostly words. Or we could use a colon between the two numbers, and we actually say the same thing. We say 18 to 15. And the last method is the fraction form, 18 over 15, but you still say 18 to 15 for all of these. So when you know that it's a ratio, even though it's in fraction format, try not to say 18/15ths, but try to say 18 to 15. Ratios are always written in their simplest form. So that's easiest to see with the third example when it's in fraction format, and so you might need to use that format in order to put it in its simplest form. But for example, using this example, we could divide both the 18 and the 15 by 3, and we could say 6 to 5 or 6 to 5 or 6 to 5. Okay, so now try these ratios. There's two ratios here, one using words and one using a colon, and just put them in fraction form and in lowest terms. You might want to press pause and then check your work. So for A, we've got $21 to $28. We don't include the units when we are writing a ratio. So we'll just do it as 21 to 28. But then using our fraction skills, we'll reduce that to lower terms, recognizing that 7 is a factor of 21 and of 28, so that's equal to 3/4. And if we look at B, we've got 125 to 150, but we'll write it in fraction form, 125 to 150. Always follow the same order. So the first number becomes your numerator, the second number becomes your denominator. And then let's reduce that to lowest terms, and you could divide by 5 first, or you might recognize that 25 goes into both of these, and we end up with 5 to 6 as our simplest form. Rates are a little bit different than ratios because they compare two quantities that have different units. We still can express them in lowest terms, or sometimes we express a rate per 1 unit, so miles per hour rather than miles per 2 or 3 hours. We often reduce it, and we always include the units with rates because it's important to do that. And if we look at this first example, we could see that if I have 25 kilograms of cucumbers that are distributed over 15 jars for pickling, we want to state the rate of cucumbers to jars. So to do that, we could write it out as 25 kilograms per 15 jars. Okay, so I've included the units. And now we could reduce it. We could say that's the same as 5 kilograms per 3 jars. But we could also write that as 5/3 kilograms per jar. And the slanted line is okay for that. Or use the word per, okay, which means for every jar, okay? So per means for every. So let's try another one here. A car travels 220 kilometers in 4 hours. Find the unit rate. And again, you might want to press pause and try that. So I've got 220 kilometers. per 4 hours. So because it's in fraction format, you can see that you're going to divide. So as in simplifying, you might find that dividing is the fastest way to do that simplification, and we end up with 55 kilometers per hour. Okay. This next question has a few parts to it. Ground beef is sold in a 2 kilogram package for $8.98. It's also sold in a 5 kilogram package for $21. What's the unit rate for the 2 kilogram package? So we'll take our $8.98, and by writing the dollar sign there, I'm including the units per 2 kilograms, and we'll just divide. And we've been given a decimal, so we might have a decimal as our final step as well, and we end up with 4.49 per kilogram. So dollars always comes before the number. Rather than writing 4.49 dollar sign per kilogram, the dollar sign always comes first. For the 5 kilogram package, we'll do the same, follow the same steps. We'll have 21. Let me just do this a second. Oops. 21 dollars per 5 kilograms. So when I divide, I end up with 4.2, but because it's money, I'm going to put a 0 there so that it's always in 2 decimal places. So that's $4.20 per kilogram. Okay, and then the last step is how much do you save per kilogram if you buy the large package? Well, we can just look at the two values per kilogram and we can subtract, and we can say that we save 29 cents per kilogram. Okay, so we're saving 29 cents per kilogram if we buy the large package. And that is the end of that lesson.